Hello students, I am Professor Bokoblin. Welcome to today's lecture on quadrilaterals. Now, first off, quick recap as to what quadrilateral is. Quadrilateral is four-sided shape. So I used the example that won't overlap with later things, so to avoid confusion. So this will be the only shape I draw today that has an indent instead of being perfectly outward. So this is basic quadrilateral. It is four-sided shape. I'm not very good at drawing, so forgive me. There. That is basic four-sided shape. Let me check. Okay, you can see it probably. So this is basic quadrilateral. Good start. So quadrilateral has four sides. This is true for every single quadrilateral. Now we have to do the real tough part, figuring out what type of quadrilateral it is. First up, quadrilaterals can be split into four different categories. This is parallelograms, trapezoids, kites, or none at all, which is what the regular quadrilateral up here is, because this fits none of these following categories. So now that we know what the quadrilaterals can be, we need to know how to distinguish them. And this is what Professor Bokoblin is going to teach you. So you better pay attention. This will be on your exam. I promise that for sure. Especially if you're watching this. So, let's start with the simplest to explain. Lane, which is only the most complex because of the fact that most of you have probably never heard of it. I know I didn't learn about it until my geometry class. Kites. These are their own shape with their own rules. They are not quadrilaterals that don't fit into the other categories. They are their own thing with very specific rules. So I go to explain it. First of all, kites have no parallel angles. Parallel angles are angles that will never intersect, assuming they went on infinitely. That is the entire parallelogram. So this will never have them, but it will have two pairs of congruent or equal sides. I will represent them with a dash. This one dash right here, I'm not sure if you can see it, so I move this a little closer so that maybe you see better. Yeah, those dashes right there, those represent congruent sides, also known as equal sides. Now I'm not good at drawing, so I have to do it like this, but someone better at drawing than me. And this is also congruent. Both of these, I represent it with two lines. Okay? So, now we have the basic layout of kite. Are there any other things you look out for? Well, I'm not doing any of the angle bisecting stuff that you probably are learning about right now in this lesson. This is purely how to identify the types of quadrilaterals. So, instead, I tell you what the angles are. And these two angles will always be congruent. They will always be the same no matter what. So, in order to tell a kite, in order to be a kite, it must meet two criteria. One, it must have two pairs of congruent sides or equal sides. I'll use equal just because it's a more familiar term. The two angles here will always be equal, and then I'll discuss the two don'ts of kites. So, two pairs of equal sides and one pair of equal angles. However, there are also some don'ts for kites, which I will represent over here. let us start with bit 1. No parallel sides. Sorry, that was bothering me. And also, if other than the two pair of congruent angles, the other angles will never be equal. No, no, no. And that is due to how shape is laid out. This is something that make a lot more sense when we get to bisecting, but just know that these two angles will never be equal. Alright, so kite is probably the most complex one to explain, mostly because a lot of you never heard of it. These next two should hopefully go by a little faster, but do not count your hopes up. I will still be explaining this in great detail. So I'm going to move my recording software back a little bit so that I can work a bit easier, and that I will move it closer in order to explain parallelograms and trapezoids. So let's get started, shall we? Let's do trapezoids next. Parallelogram has longest 3, so it takes a minute. So trapezoids fit into one of two categories: regular trapezoids and isosceles trapezoids. So let us make this very clear as to what the difference is. Regular trapezoid is something like this. The basic thing for a trapezoid is that they have exactly one pair of parallel lines. Right there. This is parallel line right here. They always have 1, not 0, not 2, 1. This is very important for trapezoid, because if not one parallel sides, it's not trapezoid, and it must be in one of other 3 categories. You hear me? Good. So, and then the other side is never parallel, as I hopefully made very clear. So this is a regular trapezoid. However, there is also isosceles trapezoid. I'll shorten it to isotrap, mostly to avoid wasting you guys' time further. This is the trapezoid you are probably most familiar with. It has two parallel sides. Simple stuff. However, it has several other quirks you must pay attention to. For one, no right angles ever. Isosceles trapezoid never have right angles. Whereas with regular trapezoid, you can have right angles. You never have right angles with isosceles trapezoid. Understood? Good. So, what we do have with isosceles trapezoid, that regular trapezoids do not have, is a second pair of equal sides. This being this one, right there. The ones that aren't parallel, they are equal. And then there is also the angles. The bottom angles and the top angles will always be congruent with the other one on their side. If you can't see from over there, give me a second to move this closer so I can better illustrate what it looks like. So, this is a regular trapezoid, only parallel sides. Down here, we have isosceles trapezoid, which has one parallel sides, makes sense, 2 congruent sides, and then these 2 angles are congruent, and these 2 angles are congruent. There will always be 2 equal acute angles and 2 equal obtuse angles in isosceles trapezoid. This is very important to understand isosceles trapezoid. I accidentally hit thing, so be careful. Be careful and don't be dumb like me. So, now that we have that, let us establish the differences between regular trapezoid and isosceles trapezoid. So, I do this in T-chart, similar to what this was like, only more formal. So, we have the regular trapezoid, which I represent with T, and IT, which will be isosceles trapezoid. So, the difference here is that these ones, so this is what really make difference. I sit down so it's easier to do, but and also because at this point it's getting pretty far. So I move this over here for now. Give me a second to adjust the chair I was sitting in. There we go. That helps see better, I think. Parallelograms will likely require more movement, but so will a lot of this. It is complex, but simple. So, good. So, main difference here is that This is basic line. This only is guaranteed to have one pair of parallel sides. This is mathematical representation of parallel, two lines that never intersect. Simple stuff, if clear. This is what regular trapezoid is guaranteed to have, that no other quadrilateral does. But isosceles trapezoid can also has other rules. Alongside one pair of parallel sides, it has no right angles or no 90-degree angles. So this is very important distinction. It also has one pair of parallel sides, but also one pair of equal sides. And these are the legs, which are the parts that aren't parallel to each other. I might not be good at the terminology, but I am good at naming the shapes, so don't judge me too harshly. Okay? Okay. I don't know why I became Italian there for a second. I think I'm going crazy again. And on top of that, this also has two pairs of congruent angles. So, now we have established kites and we've established trapezoids. Over there is kites, here is trapezoids. Now, onto parallelogram. The rule for parallelogram is simple. Both pairs of sides must be parallel. No exceptions at all. So, they will always, which means there will also always be two sides that are like this. At minimum, there will be two pairs of equal length sides due to how parallelograms work. It isn't always going to be like this, as we'll see later, with rhombus and square, which you probably already know how they work. But for now, this is what parallelogram look like. Now we split it off. We split it into two categories. We split it into the rhombus and the rectangle. Now, this is very important distinction. Many try to trick you, so be careful, especially with rhombus and rectangle. It is very easy to fall into trap of thinking that they are both square when there is not evidence that they are. So, let us go through what make each unique so you know how to avoid falling into tricky trap. So, let's start with rhombus, also known as diamond, but we are not calling it diamond in this class. No. We call it rhombus. And the distinction is that it has 4 equal sides. Very simple, correct? Yes. This is what you want from rhombus. Now, rectangle, you already know what rectangle does. It has 2 pairs of equal sides and 4 90-degree angles. This is what rectangle is like. You want that to be good rectangle. And then they both recombine to make square. Square take both the attributes of the others. All sides are equal, all 90-degree angles, which I represent like that. So, we have the complete quadrilateral chart. This is a very important chart if you want to pass the quadrilaterals unit, because if you fail the quadrilaterals unit, you will fail this class. I can assure you. I am not very smart, so I'm sure you can figure out how I know. So, let us go over everything one more time. So, there are 8 shapes that you will need to memorize. And I represent it like this. I do it in this bottom section of board right here that is not taken by anything. First off, you will need to remember the quadrilateral, the basic 4-sided shape. You will also need to remember the parallelogram, the rhombus, the rectangle, the square, which I moved down here, the trapezoid, the isosceles trapezoid, and the kite. These are the 8 shapes you will need to remember to pass the quadrilaterals unit. So, I recommend you study these, rewatch this video if you have to, but these are the shapes you will need to remember. I hope to see you all next time, in the next lesson. But until then, have a good afternoon, students. I am Professor Bokoblin, out.